boys and girls, we're going to be working in Volume 1 on page 171 in math today. In this lesson, you want to be able to write an equation for an addition or subtraction problem and be able to solve it. Now, all along, we've been writing equations, and I just want to review the parts of an equation and how you can represent it with a bar model. Now, remember, a bar model represents parts, and the parts adding up to a total. We can demonstrate it by drawing this little comparison chart here. The total is on top and it's made up of the parts, and it really doesn't matter which direction you put the total on. You can put the total at the bottom as long as you understand that the parts combine to make the total. We can write two equations for this model. Right here I can show that a part plus a part equals a total, so that's an addition equation. Or I can say the total subtract one of the parts will equal the other part. And that would be an example of a subtraction equation. Alright, now just to make that a little bit more clear, I've taken a very simple example so you can make a connection to this. In this example, I'm using the problem 7 plus some number is equal to 10. Alright, so when I look at this model here, I see that these two parts have to be combined or added up to equal this 10. So I can write an addition problem for that, or an addition equation. 7 plus some number is equal to 10. And again, I can write a subtraction problem for that by putting my total first. 10 minus 7, which is a part, we'll leave the other part, so 10 minus 7 is equal to that missing part, n. And if I was going to solve this problem, I would pick this equation to write so that I could say 10 minus 7 is equal to 3. All right, and when I make this bar model, I can write two different equations for it, but one of them will be the one that I use to solve it. And then one more point I want to make here is that this bar model reminds me of a fact family. Alright, for example, if I have these two parts here equals this total, 7 plus 3 is equal to 10. That's one equation. I can do that with that fact family. Or I can turn it around and say 10 minus 7 is equal to 3, or 10 minus 3 equals 7. Alright, so all those parts are related to each other, just like in the bar model. And we use that information when we're making equations. Alright, so the I can statement, I can solve an addition or subtraction word problem by using an equation to model the problem. Alright, so take a look at this first problem. After a run, Jerry drinks 1 3/4 cup of water. His sister Emily drinks 1 1/2 cups more than Jared. How much water does Emily drink? Now they're asking us to draw a bar model. Our bar model is going to compare two parts, the amount that Jared drinks, which is here, and then the amount that Emily drinks, which we don't know. Alright, I do realize though that this is a comparison here. It's a comparison between how much Emily drinks and how much Jared drinks. And I can show that comparison in this bar model. Right, the unknown is what Emily drinks, but I know it's 1 1/2 cups more than what Jared drinks. So I can model the amount that Jared drinks as a part. This is how much Jared drinks. And then I know that if I add 1 1/2 to this, 1 1/2 cups more in this part, that I'm going to figure out this total amount down here that Emily drinks. So this will be the total amount that Emily drinks. Alright, so can I write an equation using that bar model to show how much water Emily drinks? Well, if I take the amount that Jared drinks and then I add the 1 1/2 cups more, it's going to equal this total amount, which is what Emily drinks. instead of writing total, I'm just going to put E for Emily, how much water she drinks. Alright, it always makes sense to estimate the answer first. Well, I know that 1 3/4 is about 2. And I can easily add 1 1/2 to that. 2 plus 1 1/2 is 3 1/2. So the amount of water Emily drinks should be about 3 1/2, whatever we're measuring in cups. Should be about 3 1/2 cups. Alright, now I know when I am adding these two numbers together, I do not have common denominators. And here it asks me to rename the mixed numbers with equivalent fractions using a common denominator and then solve it. Well, I know if I have uncommon denominators, I want to go ahead and stack my two mixed numbers. So over to the side, stack your two mixed numbers, and that gets you ready to rename your fractions. Alright, now I know when I'm looking at these denominators, I need to find a common multiple. So to remind me that I'm finding multiples, remember we're just going to put an M here. That's not magic, that's just reminding us, hey, we're finding multiples. Start with the larger number first. Alright, I know multiples of 4, 8, and on and on. And I'm going to stop right there because already I know that when I'm writing my multiples of 2, 2, 4, 6, I know that 4 is also a multiple of 2. So my least common multiple is equal to 4. And I know that that least common multiple is going to become my new denominator, my least common denominator. The LCM changes into my LCD. Now I'm ready to rewrite my mixed numbers. I'm going to put my equal signs. I'm going to go ahead and write my whole number 1, and then know that I have to rename this as a fraction. I'm going to find an equivalent fraction with a denominator of 4. I'm going to go ahead and do this for the bottom number 2. It's going to be renamed as 1 and something over 4. Now when I look at the top fraction, I can see that it's already 3/4. So I can think, well, I know 4 times 1 is 4, and 3 times 1 is 3. So that's going to stay the same. On my second add-in, I'm going to say that, well, 2 will equal 4 if I multiply it by 2. And I know that if I multiply my bottom number times 2, I do the same to my numerator. We know that's really like multiplying by 2 over 2, another name for 1. And I get 2. Now I'm ready to add. I'm going to add 3 plus 2, and I get 5 over 4. And then 1 and 1 is 2. Alright, well I'm almost there. But I want to recognize that this is an improper fraction. So I can simplify it. I know that this means 5 divided by 4. And 5 divided by 4 is equal to 1 whole with 1 left over. I'm going to write that as remainder of 4. I mean, 4 is my denominator, so 1 and 1/4. 5/4 is equal to 1 and 1/4. And then I'm going to add that 2 to it. So I get the total cups as being 2 plus 1, 3 and 1/4 cups. Alright, so I'm going to go back over here. I'm just going to point this. How much water does Emily drink? Well, we know she drinks 3 1/4 cup. Okay, and then we're asked to think, is that reasonable? Okay, well, our estimate was 3 1/2. And this is just a little bit less than 3 1/2. So I would say yes, our answer is reasonable. Why? Because it is close to our estimation of 3 1/2. 3 1/4 is close to 3 1/2 cups. Alright, in return and talk, they want us to think about why it's a good idea to estimate the answer to a math problem. Well, when we estimate, we come up with easier numbers to work with and come up with a solution that it should be pretty close to. Alright, so when we get our exact answer, we can reason out if our number is close to what we estimated. If it's way off, then I would need to look at it again and fix it. Okay, let's turn to the next page, and this is page 172. We're going to look closely at another problem. Right now, this is a word problem that also has a diagram in it. And that diagram is going to give us the information that we're going to use in this word problem. All right, so let's take a look at the problem. After school, Sandra walks to the library. When she walks home, then she walks home. What is the distance from the school to the library? I'm going to have to look over here at my diagram to get that information. All right, and I can look at this diagram, and I can see that from the school to the library is unknown, but then from the library to home is 1 3/4 miles. I know the total that she traveled is 5 2/8 miles. This practically looks like a bar model. My total is 5 2/8 miles. And then these two parts, which I'm going to represent at the top, will make up this total. I don't know this distance right here, that's my unknown, but I know this is 1 3/4. It says here I can write an addition equation and then a related subtraction equation to model the problem. Okay, and that goes back to what we were talking about before. I can write two different equations for that bar model. If I look at the bar model, I know that this part and this part has to add up to the total. Alright, so instead of writing a question mark, I'm going to use a D, it says, for the school to the library. Alright, so instead of a question mark, I'm going to put a D. So I know that my addition is D plus 1 3/4 equals 5 2/8. That's my addition equation. Now I can write a related subtraction equation. I take my total, 5 2/8. I subtract the known part, and that will give me the other part that's going to be equal to my distance. Okay, now I'm ready to estimate. Well, I know that 5 2/8 is very close to just 5. And I know that 1 3/4 is almost 2. So using some very easy numbers to work with, I have 5 minus 2, which is 3. So I know my answer, my D, should be about 3. Well, when I'm solving this problem, I have to rename the mixed numbers as equivalent fractions with a common denominator, and then find the distance. Explain the process that you used. Alright, well, the process we use in class is we stack our mixed numbers because we see they have unlike denominators and we know we're going to have to rewrite them. So over to the side here, I'm going to stack them. Alright, so we'll just call that stack. And we know what that means. We're going to stack, then we're going to find the LCM. Alright, so I'm going to look at my denominators, and I'm just putting that M up there to remind me I'm finding multiples, not factors, but multiples. I'll put that 8 and 4. I know the first multiple of 8 is 8, and I'm stopping there because I know that 8 is a multiple of 4 also. So I know my LCM is equal to 8. And that LCM is going to become my LCD, my least common denominator. It's a denominator they have in common. Alright, so now I'm ready to write my equivalent fractions with my new denominator. So my process is write equivalent fractions, and I'm going to just put equal fractions fractions with your new LCD. And we all know what LCD means. Alright, so my LCD is 8. So I'm going to put 5 and something over 8. And then 1 and something over 8. Well, up here, 8 times 1 is 8, so this is going to stay the same. 2 times 1 is 2. On my bottom add-in, or excuse me, that's not an add-in, it's subtracting there. On my subtrahend here, I'm going from 4 to an 8. Now, how can that be? Well, I know if I multiply by 2, that would equal 8. If I multiply the bottom by 2, I do the top by 2. Because that's another name for 1, 2 over 2. 3 times 2 is 6. Alright, so we've done the hard part, but now we see that we have to subtract 2/8 minus 6/8. 2/8 is not large enough to subtract 6/8. So I know I'm going to have to rename. Alright, I'm going to have to crunch this up here, so watch carefully. I'm going to mark out my 5 and make it 4. Okay, I'm going to put this right over here. Here's what's going on here. I'm marking out my 5. I'm going to leave 4 and 8/8. So that 8/8, I know I'm going to regroup with my 2/8. Alright, so in class we do that little peanut thing. 8/8 plus 2/8, we know is 10/8. Okay, and now that's big enough to subtract. 10/8 minus 6/8 is 4/8. And then 4 minus the 1 is 3. Okay, so I know that my answer is 3 4/8, which is equal to 3 1/2 miles. Is it reasonable? Yes. Why? It's close to 3. Alright, I'm going to refinish writing this process. We stacked them. We found the least common multiple. We wrote equivalent fractions and changed that multiple to our LCD. We renamed fraction to subtract. And we got our answer, which is the difference. Alright, now we are ready to do check understanding. You're going to need a whiteboard or another piece of paper to work these out. The bakers spend 4 1/2 hours at the beach. They spend 2 3/4 hours in the water and the rest of the time on land. Write an addition equation and a related subtraction equation to find T, the amount of time they spent on land. How much time did the bakers spend on land? So we're asked to write 2 equations using this information. We know that the total was 4 1/2 hours at the beach. We know that they spent 2 3/4 hours in the water. 2 3/5. And then they said the rest of the time was spent on land. So I know that the amount of time they spent in the water and the amount of time they spent on the land have to add up to the total, the 4 1/2 hours they were there. I can write 2 equations for this model. I can write an addition equation and then I can write a subtraction equation. The total minus the part that I know will equal the part that I don't know. Now when I go to solve this, it would be useful to use this equation. When I solve this, I need to stack the problem. I'm going to look at my two denominators and find a common multiple. I'm going to stop at 10 because I know that 10 is also a multiple of 2. My LCM is 10. That LCM is now going to become my LCD. So it's time to write an equivalent fraction with the new LCD of 10. To write my equivalent fraction, I say 2 equals 10. How? Well, 2 times 5 is 10. Now I just got to find the numerator, and I do it by multiplying it also by 5, because 5 over 5 is another name for 1, and that's just using that identity property. 5 times what is 10? 5 times 2. Multiply my numerator by the same amount, and I get 6. Now I need to subtract. However, 5/10 is not enough to take away 6/10. So I'm going to have to regroup. I'm going to mark out my 4, and I'm going to leave 3 of the 1s, and change that 1 that I'm taking away from it into 10/10. I made it 10/10 so I can add it to this. So now this can technically, it can borrow the 10/10. The peanut, 10/10 plus 5/10 is 15/10. Now it's large enough to subtract. 15/10 minus 6/10 is 9/10. And 3 minus 2 is 1. So I know that this missing amount over here that they spent on land is 1 9/10. I can check that by saying 1 9/10 plus 2 3/5 and seeing if I end up with 4 1/2. And it does check out. You're going to do number 2 to find out how many hours that Lexi is at the photo shoot. It asks you to write a couple of equations for that and then solve it. Page 173. You're asked to model this problem. Jason makes a kite that is 3 7/12 feet tall. Annie makes a kite that is 1 1/4 feet taller than Jason's kite. Draw a model to represent the problem and write an equation and find out how tall Annie's kite is. Okay, once again, we're doing a comparison. To find Annie's height, we're going to add 1 1/4 feet more to get the total height of Annie's kite. So let's model this comparison with a bar model. Alright, I'm going to put Annie's kite up here, or Anne's kite. Now I know that Jason's kite is 3 7/12 feet long. And it says that if I make it 1 1/4 feet longer or taller than Jason's, it'll be the length of Annie's kite. So I need to add 1 1/4 to Jason's kite and combine those, add them together, and I will get the total. So my addition equation for this is going to be 3 7/12 plus 1 1/4. You're going to have to stack those. You're going to find a common multiple. And then you're going to have to write an equivalent equation and find your total. Let's look at number 4. David has 3 4 cups of flour. He needs 2/3 to make biscuits and another 3/4 to make baguettes. Does David have enough flour? How much flour does David need? Or have left? Well, we know that David has 3 1/4 cups of flour. He needs 2/3 cup to make biscuits and another 2 3/4 to make baguettes. So I'm going to do a comparison here. I'm going to add together 2 3/4 and 2/3 to see if it equals 3 1/4. So I want to combine these two amounts and then compare that total to 3 1/4 to see if it's enough. Okay, you're going to solve those problems 2, 3, 4, and 5. And I want to look at 5 because it has more than 2 parts to this problem. And so sometimes you can have more than 2 parts that add up for a total. In this problem, we have a house that has 2 stories and an attic. So that's 3 different floors that it has. The first floor is 9 1/2 feet high. The second is 8 3/4 feet high. And then we know that the entire house is 24 7/12 feet high. What is the height of the attic? That's that third part. Well, how am I going to model that? Well, do I know the total amount? I do. The total amount is 24 7/12 feet. And then I know we have 3 different floors that we're looking at. The first is 9 1/2 feet. The second is 8 3/4 feet. And the third, we don't know. Some number. But I do know that these 3 parts have to add up to that. Or this, subtract these 2, is going to equal this. So how do I solve that? I'm going to have to add these 2 together. So this is going to be several steps. 24 7/12 minus, there, I'm using parentheses because remember parentheses means do that first. And then what I'm left with is going to be my answer. So you can see I need to add these 2 first, get common denominators, and then subtract it from this. Alright. You're going to work problems 2, 3, 4, and 5 for your work today. Good luck on that, and make sure you submit your answers on Google Forms.